Let's talk about the strong force. Within this module, we'll be talking about nuclear force, pions, short-lived particles, gluons, and quarks. So the strong force is one of our four forces that we've been learning about, and the pictures so far that we have seen of the nucleus of the atom have shown the protons and neutrons clumped together. But from everything that we've already learned, we know that when you have positive protons next to positive protons, that they repel each other. So how is it that they can stay together when packed tightly inside of the nucleus? Scientists believe there's a short-range attraction force that's called the nuclear force that attracts both protons and neutrons to each other. So something is holding these together that's stronger than that repelling force between the positive protons. In the beginning, scientists knew a force must exist to hold the protons and neutrons together in the nucleus. But until 1935, no one knew what that force was. In 1935, a scientist named Hideki Yukawa proposed that the protons and neutrons exchange tiny particles called pions. And he also predicted what their mass would be. Now, this was not a far-out assumption because we already knew that atoms exchanged particles, and so for them to exchange other particles that were perhaps smaller made sense. The mass and the existence of pions was actually confirmed by experimentation in 1947, and Yukawa received the Nobel Peace Prize for this process in 1949. The nuclear force is similar to the electromagnetic force, which we've learned about. Both forces exchange particles. However, protons can exist for a very long time, whereas pions are short-lived particles. For pions to be created, protons and neutrons must stay close together to exchange the small amount of charge that they actually must give off to create the pion. So they actually lose some of their charge when they create the pion. So they have to do it very quickly because the nuclear force can only operate over very small distances before that force basically runs out. The nuclear force is one aspect of the strong force. There are other forces involved in the strong force, and protons and neutrons are made of 3 smaller particles. So these particles are called quarks. And quarks are also busy exchanging small particles called gluons. Gluons hold quarks together so that they can form protons and neutrons. So to bring all of that together, the strong force only holds the nucleus together via the exchange of pions. But the strong force also holds quarks together via the exchange of gluons, allowing the existence of protons and neutrons. So as the name implies, the strong force is very strong. In fact, the strong force is considered to be the strongest force in creation. Without that strong force holding together the protons and neutrons in our nucleus of our atoms, nothing could exist. So go on to do your own problems, and if you have any questions, be sure to contact me.